All right. So you think that you have compound inequalities down. Great. Now we're going to move into absolute value inequalities. And absolute value inequalities really are the same thing as compound inequalities because we're going to end up with either an arrow that looks like two separate inequalities graphed on the same number line pointing in different directions like this, or you're going to end up with that baton looking thing, which would be a conjunction, right? Either a disjunction or a conjunction. Now, the simple reason why this works is because when you have an absolute value, you're saying both positive and negative values will work for the same exact equation or inequality. So let's, instead of trying this guy right here, let's be good problem solvers and let's actually try a slightly more simple problem. Part of being a good problem solver is being able to simplify a problem and do it in an easier way, and then build on that and apply it to a new scenario or situation. So let's try this one right here. If you think about values for x that will make this statement true, obviously anything that's greater than 12 on our number line is going to work for this. Now, the way we would graph that, we'd do an open circle, we point that to the right, and this is absolutely true. The absolute value doesn't do anything to positive numbers. It measures the distance from all of these numbers to 0, and obviously positive numbers have a positive distance from 0, so it doesn't really change. Plug in 13, it works, right? Great. Now, what about the negatives? Let's just think about numbers for x that will work. If I plug in a number like, I don't know, -5, the absolute value of -5 is actually +5, but that is not greater than 12. So I have to rethink this a little bit. What negative number is the smallest possible number that's going to be greater than 12? And the answer to that is actually its inverse, -12. Now, when you think about this, this actually isn't a true statement because 12 is not actually greater than 12. However, 12.1 would be. And so we want to include values that are really close to 12. And the way we do that, of course, is by putting an open circle. Now, we're not talking about 12. We're actually talking about -12. Before we take the absolute value, what did we plug in for x? We plugged in -12. So like before, we plugged this in. And now, unfortunately, if I now am thinking about this in terms of values that are working, it's not going to be greater than. Again, it's not going to be greater than in the same sense, because if you think about this, if I were to plug in a number like -10, this is not going to work. -10 is +10, +10 is not greater than 12. So I actually changed directions here because I'm sort of flipping my coordinate plane. And by coordinate plane, I mean number line, half a coordinate plane. I'm sort of flipping this, and since this was pointed to the right, it will now be pointed to the left, because -11, -13, -14, -15, they'll all become positive and they're greater than 12. So this is what you end up with. And the reality is, when you have an absolute value inequality, you're always going to end up with the baton or the arrows, in this case, pointing in opposite directions. You should never end up with this situation that I'm drawing right here, where you have like two that overlap. That does not happen with absolute values. You either get one or the other, or you know you've made a mistake. So now that we've tried this simple example, can we try this slightly more complicated one? The answer is yes, of course. And first off, you think about things that will work for this. Well, solve the equation. If you solve the inequality, if you solve this, you get y is actually less than 11 now. What that does, just like before, I have my inequality sign, and it's going to be pointed to the inside this time because it's less than, and that's it. Now, if I want negative values to work, like before, I want this to be equal or pseudo equal to -12. when you think about this on our number line, that it is going to end up being a number very similar to positive 11. And when we do this, it's not going to quite work out the way we want, because we're not going to, again, be pointed in the same direction. We need to flip our sign, because if you think about this, if you plug in a really big negative number here, say negative 100, the absolute value of negative 100 is not going to be less than 12. You're going to get 100 is less than 12. That's not true. So we're actually going to, again, flip our sign. So the trick, the way to remember, is switch and flip. So this gets switched to a greater than sign, and this gets flipped to a negative 12. And I say flip because you can imagine this number line, you sort of flip a negative to a positive, or a positive to a negative, vice versa. So now that I've switched and flipped, I solve like I did before. I get y is greater than negative 13. So I have to extend my number line, unfortunately, just a little bit. And if I do that, it's still an open sign. And this time it's pointed to the middle. And so unlike the simple example that I just showed you a moment ago, this one's actually going to be the baton, the one where we just connect these two lines, and voila. Any number from positive 11 to negative 13 makes this inequality true. And you could actually rewrite that as a compound inequality. You could say y is greater than 13, but y is also less than 11, which is algebraically equivalent to this statement right here, which I told you at the beginning of this video that absolute value inequalities are just like compound inequalities, and these two are one and the same statement algebraically. It's a little thick to understand, but they are indeed one and the same. Hope that helps. If you have any more questions, be sure to hit me up on the course website, shoot me an email. I'd be happy to work with you.